I wanted to revisit the lens cross because this is sort of critical to understand in ophthalmic optics. If you actually have a prescription, -4, -2, axis, yeah, make something up, let's say 20 degrees. It's really important for you to be able to visualize how this prescription would look on someone's face, or how a lens would be oriented if it were properly positioned, what power needs to go where. So generally, if you're looking at a person, when we're looking here, as a prescription is on there, it's going to be 0, 90, 180, and then 0, 90, 180. It's always, doesn't matter if it's right or left. If you're looking at a person's eye, it's always in such a manner that it's 0, 90, and 180 as you're looking at the patient. And that's important because it's the opposite when the patient's looking out. I generally don't ask trick questions like that, but since most of what we're looking at, a pair of eyeglasses that's looking out at you when you're verifying single vision lenses, as a contact lens goes on someone's eye, it's really important that we look at the orientation of a prescription based on how we're looking at the patient. So if we go into this here, I asked in one of our homeworks to say, hey, draw this out in a lens clock. And I saw a few folks do -4. Remember, there's a sphere all the way throughout the entire lens, but 90 degrees away, there's an additional amount of the cylinder, or the full amount of cyl. 90 degrees away, there's an extra 2. So there'd be a -4 in one part of the lens, there'd be a -6 in the other, and people wrote it out there at 20 degrees, and then -60 at 90 degrees away would be 110. Now, I don't like this format. I prefer you do it in such a way that it always is actually how I look at it. This is sort of crooked, if you will. This is technically correct, but it doesn't give me an idea of what the lens looks like on their eye, whether it's eyeglasses, whether it's contact lenses. The orientation, this isn't how it really looks. So what we're going to do is, I would like you guys, when you're doing a lens cross, always draw the lens cross right out. 0, 90, 180, just like it would be in front of their eye. And let's draw the prescription on that lens cross so it always looks as it would look like in real life. So, remember, the sphere always pertains to the axis, and the cyl is 90 degrees away, so -4 is going to be found at 20. So we're going to move up by 20 degrees, or right around there, and it's going to be -4. And it sort of continues this. 90 degrees away, and this would be at 20 degrees, 90 degrees away, which would be at 110, you would have an additional, you'd have the -4 spheres throughout the entire lens, but 90 degrees away, you'd have the additional -2 cyl. So this would be a -6, axis 110. I like this format a little bit better because every time I have the lens cross always looks the same, but if I had a spherocylindrical eyeglass lens, if I put it in such a manner, I know exactly where it's going to be the thickest, where it's going to be more power, where it's going to be less power. If I had an astigmatic lens on a toric cornea, the lens powers need to physically orient just like this for that patient to see well. So every time you do a lens cross, please, please, please draw it out in such a manner that it starts like this every time, all the time. So remember, your lens cross should always start like this, 0, 90, 180. And one more example, let's just say given a prescription of let's do a +6, -425, axis 95. That would mean the sphere corresponds to the axis, so at 95, it's a +6. And then 90 degrees away, at 5 degrees, it would be the full amount of cyl. A +6 algebraically added to a -425 is, it's 75 and 175, but it's a plus. So In this particular case, this would still be a compound hyperopic astigmatism, and this would, well, we'll get into that a little bit later. This would also technically be against the rule, but I want to make sure that if you saw this on a patient, the lens should be oriented just like this for them to see well. They need a +6 here, they need a +175 there. It has to look just like this, and so I want you to do all your lens crosses based off the underlying 0, 90, 180 when you're drawing them out. Thank you.